Okay, so sir, I think we can start now. So, okay, so today we're going to be, as we've advertised, I will be holding a free tutoring class for ninth or for 10th and 11th grade. So the topic we will be discussing will have a 1 hour class for math for trigonometry today. Um, so before we start, I would like to hear from our principal, sir. So, sir, the floor is yours.
Good afternoon, everybody. First of all, I would also like to welcome all of you. I don't know how many students have joined, but I expect all our students who are in 10th class and 11th class. So, you know, Mr. Uh, Mr. Asher on that day, he gave demonstration. That was another field, but today you will have these tutorial classes. You know that he's really very intelligent boy, and since he came here, he's the topper of every class. So I hope, and in 11th also, his performance is very good. He's very capable. So inshallah, next year he will be in +2. I mean to say in 12th class. So this is his own effort, his own venture, uh, new type of, this task. In our school, no boy had that gut to help our juniors or colleague or classmate. So it's very kind of him that at least he has taken this step just to help the school fellows. So I hope it will be very useful session for 1 hour. And as and when he will get time, he will inform you. So he will also have in future also some classes. So quite possible he will continue in 12th class also. So you can solve all your problem wherever, as far as regarding this trigonometry. It's a really very difficult topic, and when you understand once, then it will be very easy. So some formulas are there, but there are some technique to remember these formulas. So he will tell you how to solve all this. So I mean to say, utilize this session. Don't be hesitant. Don't be shy. Whatever problem you might have completed this trigonometry in the class, your teacher might have completed, but still some of the students might not grasp the complete uh, this trigonometry. So today it's a chance for you to solve all your problem regarding to trigonometry, and whatever difficulty you are having, you can share. So he will certainly explain each and everything. And by the end of this session, you will feel that we have learned something new. So all the best. I wish you all, and I hope this session will be very successful. You will all remember it. Thank you very much.
Okay, sir,
Mr.
Jazakallah. Yes, sir. I think we should wait for a few students because so far nobody has joined.
How many students have joined?
Sir, so far no one.
I
S-
see.
I believe I think Sarfaraz joined, but he disconnected. Maybe he has network issues.
Uh-huh.
So
Any girl?
No, sir. No, so far nobody has joined.
In fact, they are informed, but very late. I saw this message very late also.
I see.
So uh, I couldn't inform ma'am, but ma'am might have got this. She also, so she has already informed.
I see. So no
Uh,
problem, sir. We can wait for 5, 10 minutes. If not, I can still hold the lesson, and those who who haven't been able to attend, they can watch the recording since I'm recording this anyway. So
quite possible because of Friday. Some student
yes,
maybe
sir.
some might have gone to Makkah, Medina, or maybe some other program also.
Yes, sir.
Uh, so it's better uh, have on Saturday. I will say, or
I
in the
see.
evening sometime.
Sir, one
Or
student has joined, Arshia Sultana. So
I see.
we can start
So
after this. I think, sir, they might be a little bit late, so we can just wait for 5 more minutes and then
yeah,
we can.
yeah. Wait, quite possible they may join late.
Yes,
So
sir.
only because of Friday, So,
Yes, sir.
uh, so so many, work are there on Friday. So that's why people are busy.
Yes, sir.
And who
Yes, sir.
knows that
They're joining now.
they,
The another student
some
has.
of your fellows will be sleeping also.
That's very possible, sir. Yes. Sir, so the students are joining now, so I think they were just
They will
maybe.
join.
Yeah.
They will join. Uh, so see that how many are there. In fact,
Yes, sir.
girls were found very, very late.
I see.
Uh, so let's see how many are there. Just let me know in the end how many girls, how many students joined, so
Yes,
that
sir.
we can brief them on the Sunday in the class. So that, of course, if the lesson is interesting, they will certainly join. Then this student will tell other student, so they will join it. Right?
Yes, sir.
So, okay, thank you very much. Huh?
Okay, sir. Jazakallah khair.
Okay, I'm just going to take food.
Yes, sir.
After that, I have to go out.
Okay.
Huh?
Yes, sir.
Okay.
That's fine.
Thank you very much. Thank you.
All right. So I think we'll wait for 5 more minutes, see if anyone else joins, then we'll start. All right. Okay. So we see a few more people are joining.
This one is me.
All right. So I think we can start now. So before we start, I would just like to introduce myself for those of you who don't know, although I'm pretty sure most of you are familiar with me. We play volleyball together and everything. So as you know, my name is Rayyan, Rayyan Asher. I study in grade 11. And this is an initiative that I've taken for free tutoring for, school or my juniors to help them with their studies because I know 10th is a very important year, board being there and all. So I thought, why not, since I've been through that experience, why not help out? So currently, as I said, I am in grade 11. And today we are going to be studying about trigonometry. But since I've been already informed that you guys have taken in the chapter Introduction to Trigonometry already in term 1, we will be discussing the applications of trigonometry today. So that is, as you might have known, maybe if you've seen other books, they call it heights and distances in some books. So why is it called heights and distances in some books? Because we are using this is the application of the trigonometric ratios, that we use the trigonometric ratios to find heights and distances of different we can say buildings or things like that. So in fact, if I'll just switch the screen to the NCRT textbook. If you guys have the NCRT textbook, you may refer to that as well. Um, so just give me a second. So as we can see here, this is the NCERT textbook. Now, I'm sure you guys have already gone through this with your teachers, and of course, they're very competent at what they teach. But I thought, just in case if someone hasn't understood, I could give this, class from the point of view of a student. Because while teachers, they know everything, sometimes students have certain problems which teachers may not be able to help with. So as we can see, so the chapter is named Some Applications of Trigonometry in your book of NCRT. And if we start off, so we have, okay, so this is something, this is a good example where I want to touch on. So we have given here, I'm not sure why I can't scroll down. Here we go. Okay. So what we have here up here, it says it's given a little can say a little information about the theodolites. So I'd like to hear from you. What do you think a theodolite is? Sorry, from some of the students. What's your understanding of a theodolite? Anyone? What do you think this device does?
Measuring angles.
Okay, but what type of angles? What is the importance of measuring a certain angle?
While in a telescope, actually, while moving the direction, like changing the direction of a telescope.
Yeah, so you're on the right track. So what a theodolite is basically it uses the principles of trigonometry, which you would have learned in the previous trigonometric chapter. It uses those we can say principles to measure the size of an object. In fact, the theodolite was actually the instrument that was used to measure the height of Mount Everest. It was commissioned over here, as you can see, during the survey of 1852. The highest mountain in the world was discovered. The theodolite, one of the biggest theodolites in the world, was commissioned by Sir George Everest. As you know, it's called Mount Everest. And he used the theodolite and trigonometric ratios to find the height of Mount Everest. So how does it work? So this is where we're going to study the applications of um, heights and distances and trigonometry in determining heights and distances. So if I start annotating here, so let us say, for example, I'm pretty sure you must be familiar with the Qutub Minar in India. It is a big, huge tower. This tower right here. Wow. Okay. Well, I can't write. My bad. But so what it basically does is it's a very high tower. So how would you find the height of this tower? As we can see, it's heights and distances. So what happens is, let us say you're standing at the base of the tower right here, and you're looking up at the tower, at the top of the tower, and you know that this distance from here to here, you know how far you're standing from the tower. So if you look at this, we know that it is, I mean the tower is
Excuse
obviously
me.
upright.
I'm sorry to interrupt.
Yes, sir.
The screen is not shared.
Uh,
Sir, it is shared in mine.
sir,
So it's
I believe
visible
it's
clearly. So I
shared.
guess it's yeah,
I,
it's visible clearly. I guess network issue. It's
yeah, sir,
Okay,
I've
okay,
shared it.
carry on.
Yeah, it is shared.
Okay, so um, in the previous chapter, we learned about different, we can say trigonometric ratios like sine, cos, etc., etc. So how do we put that into application in real life? So, like I took the example of the Qutub Minar. As we know, the Qutub Minar is upright. It's not, angled like the Tower of Pisa. So it is obviously perpendicular to the ground. So what we do is, if you're looking up at the Qutub Minar, your line of sight to the top of the minar of the tower, if you look at it, and your distance from the tower, if you look at it, it just makes one big huge right angled triangle. And as we know, trigonometry is used in right angled triangles, as we know. So if you were to try to find the height of this tower right here, Qutub Minar or whatever, whichever tower you want, Burj Khalifa for all of us living in the Gulf, when you look up at the tower, you have a certain inclination, right? Like you tilt your head up. I mean, you can't have your eyes on the top of your head, obviously. So you look up, you tilt your head a certain angle from where you would look normally. So where you would look normally is called the horizontal line of sight, which is this. And the angle between your horizontal line of sight and the line of sight towards the top of the tower here, we can say this angle as theta, and it is called the angle of elevation, which means how much do you elevate your head or elevate your eyes to view the top of the tower. So I know this sounds a little crazy right now because we haven't gotten to it. So I just want to go over a few terms. So we have line of sight, which we can determine as hypotenuse. We have angle of elevation, which is theta, and we need to find the height of the tower, which we can find as h. So what we do is we can use different trigonometric ratios to find this height h. How do we do that? Well, we have the distance that you're standing from the tower. This is ed. This angle of elevation theta. So if you look at it from a, I guess you could say, a trigonometric standpoint, essentially what you have is we have a lot of students joining, so I'm unable to write. But so what we can see is, if you look at this from a trigonometric point of view, what we have right now is theta and also ed. What is ed? It is the base of the triangle. So we have the base. So what is left? We have height, right? So we know which trigonometric ratio uses base and height in theta. I would like to hear from
Tan, cot.
Tan.
exactly. So we can use tan or cot to find this perpendicular. And what is that perpendicular? The height of an object. So this is how we will use trigonometric ratios in the um,
Application.
yeah. No, Sir Faraz, I can't exactly disable because I can't disable the meeting room or the waiting room because I need to know who's joining. So I need to keep that there. So this is an introduction, and I know it's a little haphazard. This is my first time teaching. But so basically what happens is the angle of inclination is your theta, and the distance from your, what we can say, your distance from the object that you're measuring is the base, and the height of the object is the perpendicular. So if you know theta and base, out of these three quantities, if you know any two, the third can be found. Similarly, if you know how far or how high the tower is, then you have h already. You have theta here. So if you have h and theta, then you can find base, because you can use, again, cot you can use, which you have h is, we know that cot theta. Oh, wait 1 second. We know that cot theta, if we take this example, is equal to base by perpendicular, right? So that is AB by h, which is BC is h, because we know the height already. So mainly, if you look at this, most of the questions that you will attempt in this chapter will be using cot and tan, because we will most likely have to find the height or the distance from an object. So just remember that cot and tan are usually used in this chapter. There are some, what we can say, applications of sine and cos as well. Sometimes, like for example, we'll come to that question later, but if you have a ladder, for example, instead of a line of sight, you have a ladder, you need to reach a certain height. You need to find the length of the ladder. That is a hypotenuse. So that's where you will use sine and cos, etc., etc. So now that you have a basic understanding of the chapter, we can move on to certain examples. So in fact, actually, before we move on to the examples, let's look at the description of NCERT, what they have written. So we have given figure 8.1, which is redrawn as it says. So in this figure, the line AC drawn from the eye of the student to the top. Wait 1 second, let me just erase this. Okay, so the line AC drawn from the eye of the student to the top of the minar is called the line of sight. As I explained, the line of sight is basically the hypotenuse of the triangle, the right angle triangle. And the line of sight is basically where your eyes are looking when you look at the top of the tower. Student is looking at the top of the minar. The angle BAC so formed, which is this BAC, is called the angle of elevation, which we already saw is theta. So, so the angle BAC so formed by the line with the horizontal. So, like I said, the horizontal line of sight where you would normally look when you look straight ahead, your head is at a 90-degree or a 90-degree angle. You know, like from the ground, like it's a normal head. You're just looking forward. That is the horizontal, which we call the horizontal line of sight. And the inclined line of sight is this AC, and the angle BAC is theta. So the angle of elevation to the top of the minar from the eye of the student. So then we have thus the line of sight is the line drawn from the eye of an observer to the point in the object viewed by the observer. The angle of elevation from the point is viewed is the angle formed by the line of sight with the horizontal when the point being viewed is above the horizontal level in case when we raise our head to look at the object. Again, so this is a very important point that I want to touch on. The angle of elevation is only elevation, which, I mean, this sounds obvious, when you elevate your head, which means when you look up. If you're looking below the angle of or the horizontal line of sight, it's called something else. So the angle of elevation is only applicable when you're looking up, which they put here in case when we raise our head to look at the object. So moving on. One second. We have, let's take for an example here. As I said, we use tan and cot. I use theta, they use A here, given any angle. So um, next, let's come to angle of depression. So this is the converse of angle of elevation. So what happens here is when you're looking below the line of sight, this is called an angle of depression. This is again theta, but here you can't use this right angle triangle exactly because the horizontal level is here and looking down. So what do we do? Well, we know this line, or actually let me draw that with a straight line. We know this line right here, if we look at this diagram, this line is called our horizontal line of sight, yes? And this line right here is the ground or where the object is. And what we can see here is that these two lines are perpendicular, or not perpendicular, sorry, parallel, right? As we can see, they're both, if we extend them, they will never meet no matter how far we extend them in this direction, right? So what can we use here? I would like to hear from you. What do you think? How can we make the angle of depression into an angle of elevation or a usable angle? I'd like to hear from the students. Anyone?
Angle of depression is the is equal to the angle of inclination because it's the alternate interior angle.
Yes, exactly. So, like Bashar put it, exactly, that's correct. As we can see, the line of sight below the horizontal level and the ground are parallel, and the line of sight is acting as a transversal. So you guys must have studied this in geometry. A transversal is a line that intersects two parallel lines at certain angles. And we also know that, opposite, as he said, interior opposite angles are equal. So using that, since we have the line of sight as the transversal, this angle theta will be equal to this angle theta due to them being opposite interior angles. So moving on, let me just 1 second. Right. So moving on, as we see the what we can say the explanation given here. So it says now consider the situation given in figure 8.2, this figure, or well, it's numbered 9.3. I believe that they have to update this figure here. They have a typo, I guess. The girl sitting in the balcony is looking down at a flower. Again, it's not a flower pot, it's a football, but I think they need to again update it. Looking down at a flower pot pasted on the stair of a temple. Or am I looking at the wrong diagram? I might be looking at the wrong diagram. Anyway, both the diagrams are the same thing. Um, no, yeah, they have to update their thing. So anyway, as I said, consider the situation given in figure 8.2. The girl sitting on the balcony is looking down at a flower pot placed on the stair of temple. In this case, the line of sight is below the horizontal level, as we saw. The angle so formed by the line of sight with the horizontal is called the angle of depression. So this is very, very important when you make a diagram. First of all, you need to indicate the line of sight. So these are some tips that I think you guys should know. When you make a diagram, for example, this one, either you tell them, either, you can write the angle of depression, like you show the line of sight and you say angle of depression. You need to get that right because you need to clarify what angle it is that you are using. Or you can indicate the line of sight with an arrow, this is actually something I did in grade 10. One thing that you should do is always indicate where the person is looking. So you should use an arrow to show where the line of sight is. So as we know, the angle of depression of a point uh, on the object being viewed is the angle formed by the line of sight with the horizontal when the point is below the horizontal level, as I said. Um, so again, when it's below the horizontal level, it's called an angle of depression. When it's above the horizontal level, it is called angle of inclination or angle of elevation. So um, now I think we can, we have a basic idea. We can take certain examples because, practice is the best way to understand how to use these. So the first example is very, very, very simple. We'll take this. A tower stands vertically on the ground. From a point on the ground, I believe we're going to run out of time, so you guys can rejoin after this. So let's take the first example. A tower stands vertically on the ground, which means 90 degrees right here. Whenever obviously it says vertically on the ground, it's going to say 90 degrees. And obviously you're going to be dealing with nothing but 90 degrees in this chapter because anything else would be out of your syllabus. So a tower stands vertically on the ground. From a point on the ground, which is 15 meters away from the foot of the tower, the angle of elevation to the top of the tower is found to be 60 degrees. So we are given the angle of elevation, which is theta is equal to 60 degrees. We are also given that the point where the angle of elevation originates from is 15 meters away from the foot of the tower. So we have base, which is BC, is equal to 15. So now we have to find the height of the tower, AB. So we don't know AB, right? So 1 second. Okay, I'm gonna cover the solution because we're gonna solve it here. Give me 1 second. So if we go about to solve this, we know that we already have the base and we have theta. This is quite a straightforward question. So if we have base and theta, we need to find perpendicular. So what do we use? We use tan, right? When we use tan, we have theta is equal to 60. So tan 60 is equal to base, which is, or perpendicular, which is AB upon base, which is BC. And what is the value of tan 60? Anyone?
Root
Root
3.
3.
Root 3.
Exactly, root 3. So we have root 3 when we substitute the values. So we have tan 60 is equal to root 3. We use the value of theta as 60. So tan 60 is equal to root 3. We know that AB, let us say, we don't know AB, so let us keep it as AB. And we know BC is 15. So then it's very simple, just, this goes up here. And we get the value of AB as 15 root 3 meters. So this is where you can use, your application of trigonometry. So this is the first example. So these examples are very straightforward. However, I would like to touch on one topic, which is when, for this next question actually is a good one because one, it uses sine, and two, it, I guess you can say is a little different because many times what people don't understand is you always don't have to take the line of sight from your feet. It's not always there. Like sometimes sometimes in certain questions they have a person who is like 1.5 meters tall is looking at a tower. So in certain, or for example, the person's height, like in this question here, says an electrician has to repair an electric fault on a pole of height 5 meters, but she needs to reach a point 1.3 meters below the top of the pole to undertake the repair work. That means this person is 1.3 meters tall. So we need to account for her height when she reaches the top. So she doesn't need to reach the top. She needs to put her ladder um, on a place where she can stand up tall enough so that she can repair the fault. So many times we need to take into account the height of a person as well. So in this case, 1.3 meters is the height of the person. So if we go about, solving this question again, so what we would usually do is, we would, 1 second. We would say, oh, we have the height as 5 meters. We have the angle as 60 degrees. We just need to find out the hypotenuse. Again, another thing I would like to touch on here, we need to find the height of this ladder. And then to find the height of this ladder, we can't use tan because this ladder is the hypotenuse. We'll be using one of the formulas using hypotenuse. So that is like sine, cos, etc., etc. So when we go to solve this problem, most people would, they commit this mistake that, oh, I know I have, AD, this entire length right here as 5 meters. I have theta is 60. I can just use tan or whatever hypotenuse formula, sine, cos, etc., to find the entire value. But the mistake they're committing is that they're not taking into account how much of the height that we can say this girl needs to reach for her work to be done. So the actual height, the apparent height that we need to find is actually AD minus AB. And we know that we are given that AD is equal to 5 meters. So this is 5 minus, we're given she needs to reach a point 1.3 meters below the top of the pole. So she doesn't need to reach the whole 5 meters. She needs to reach 1.5 meters below the pole. So AB is 1.3 meters below the pole. So what we do is we need to find the apparent height. And how do we find that? We subtract the height of the person from the height of the pole. So 5 minus 1.3, anyone?
3.7.
3
Yes, 3.7. So we have 3.7. So this is actually the height we need to use in our formula. We don't need to use 5, we need to use 3.7. Now it's, again, very straightforward. We have the height, we have theta, we just need to find hypotenuse. We can use sine is equal to perpendicular, which is 3.7 by hypotenuse, sine 60, sorry, here, by hypotenuse, which we can keep as BC. So what is sine 60? Root 3 by 2, right? So sine 60 is equal to root 3 by 2, which is equal to 3.7 by BC. So then we can cross multiply. So we get 3.7 times 2 divided by root 3. This will come to approximately 4.28 meters. So the height of the ladder actually needs to be 4.2 meters, rather than if we had used 5 here, we would have gotten 10 by root 3, which is much more different than 3.7 by root 3, because 3.7 times 2 is 2 fours, 2 sevens are 14, 7.4. So we can see there's a difference of almost 3 entire meters just in the reading. So the reading will be inaccurate. So these are, again, very, very straightforward questions. We will be moving on to a little bit of harder questions. So this question right here is better because here we have a compound triangle. So we have 2 triangles, one is superimposed on the other. These are the types of questions that are a little longer in this chapter, and they might need a little more focus from those solving them. So if we go to solve this question, we are given that the shadow of a tower 1 second. So the shadow of a tower standing on level ground, again, standing on level ground means that it is at 90 degrees from the earth. So we have 90 degrees there. Standing on level ground is found to be 40 meters longer. The shadow of the tower standing on level ground is found to be 40 meters longer when the sun's altitude is at 30 degrees. So we have angle of elevation as 30 degrees. Than when it is 60 degrees. Find the height of the tower. So let us take, for example, let us take this BC length, which is the original shadow at 60 degrees as x. So we have x is equal to BC. And we know BD is equal to BC plus 40, because it's said that at 30 degrees, it is found to be 40 meters longer than when the sun's altitude is 30 degrees. So first, what we're going to do, we're going to take in triangle ABC. What do we have? We need to find the height. Let us take this as h. Well, this is height is h, yes? So if we have height as h, then again, we can use tan for the formula for tan. So we have tan 60, which again, as you guys said, is root 3, is equal to perpendicular h by base, which is x. So that implies that tan 60 is root 3 times x, when we move this up here, is equal to h. So the first value of height is equal to root 3 times x. Now what we will do is we will take triangle ABD, the triangle that is bigger and which contains triangle ABC inside, because since we have two we can say two variables, h and x, we need to have two equations to solve those variables. So the second equation we will get from ABD. So in triangle ABD, again, we